All right, today we're diving into a theory, a really big one that could potentially flip everything we think we know about the brain, consciousness, and maybe even the origin of life itself.
You've probably heard it a million times, right? The brain is a computer. A wet computer, they say. Just a bunch of on-off switches called neurons all firing away. But what if that's not just wrong, but like profoundly wrong? What if calling the brain a computer is like calling a full symphony orchestra a drum machine?
So here's the classic textbook picture of a neuron, just a simple little on-off switch. But honestly, this view is a massive insult to what a neuron actually is. I mean, think about a single-celled organism, like a paramecium. It has no brain, not a single synapse, and yet it can hunt, it can learn, it finds mates. How? It's using its internal microtubules as a kind of proto-nervous system. That right there tells you there's a whole universe of complexity happening inside every single cell that we've just been, well, kind of ignoring.
In that little internal nervous system? That brings us right to the absolute star of this whole story, the microtubule. The theory we're looking at today proposes that these tiny little protein cylinders inside our neurons, they aren't just scaffolding holding the cell shape. No, there's something way more exotic. They might actually be a biological time crystal.
Okay, so what in the world is a time crystal? I know, it sounds like something straight out of science fiction. But think of it this way. A normal crystal, like a diamond, has a pattern of atoms that repeats in space. A time crystal, well, its pattern repeats in time. The best analogy is probably a set of nested clocks. Clocks inside of clocks, all ticking away at different speeds, but all perfectly in sync, all harmonically related.
And this isn't just a wild guess. A physicist named Anirban Bandyopadhyay and his lab made an absolutely stunning discovery. They found that these microtubules, they literally resonate. They vibrate with a whole orchestra of frequencies, and I'm not talking about a small range. We're talking vibrations from Hertz all the way up to Terahertz, all happening at the same time in the same tiny structure. And get this, each level of frequency is about 1,000 times faster than the one below it.
And these aren't just random jitters either. Each frequency corresponds to a specific part of the microtubule itself. So you've got these flexible little tails, and they're vibrating in the kilohertz range. Then the main protein structure, the lattice, that's vibrating in the megahertz range. And the water that's trapped inside the core of the microtubule, that's humming along in the gigahertz range. It's literally a symphony.
Okay, so let that sink in for a second. If this is actually what's happening, the implications for how we think the brain works are just, well, they're staggering. It could mean we've been looking at the whole problem from the wrong level of detail this entire time.
And Dr. Stuart Hameroff, who's a huge figure in this theory, put it perfectly. He said focusing on EEG, the main way we measure brain activity, is like going to a symphony and only hearing the bass and the percussion. You're getting the slow, thumping rhythm of the neurons firing, but you are completely, utterly missing the lightning-fast melody being played by the violins, the flutes, the piccolos, the microtubule.
I mean, the difference in the sheer amount of information we're talking about here it's mind-boggling. Just look at this. An EEG measures brainwaves up to what? Maybe 100 cycles per second? The vibrations inside a single microtubule can hit 1 trillion cycles per second. That is 10 orders of magnitude more bandwidth. It means our brains might be processing information on a scale we haven't even begun to comprehend.
And this brings up another huge puzzle, memory. Right now, the standard model says memories are stored in the connections between neurons, the synapses. But here's the problem. The actual proteins that make up those synapses, they only last for a few hours or maybe a couple of days. So how? How do you store a lifetime of memories in something so temporary? It doesn't quite add up, does it? But an incredibly stable, complex structure like the microtubule lattice inside the neuron, well, that starts to look like a much better candidate.
And look, this isn't just some abstract philosophical theory. It has real-world implications. It offers a totally new way of thinking about devastating diseases like Alzheimer's. For decades, the entire focus has been on those amyloid plaques that build up between neurons. But this theory suggests that maybe we've been looking in the wrong place all along.
From this perspective, the real problem starts inside the neuron. It turns out that the actual cognitive decline in Alzheimer's patients lines up much better with the collapse of these microtubules than it does with the amount of plaque. So what happens is, these little proteins called tau, which normally hold the microtubules together, they detach. And when they do, the whole structure it disintegrates. It falls apart. The neuron's whole transport system breaks down, the synapses pull back, and, well, that's when memory is lost, that's when the brain actually shrinks.
But here's where it gets really interesting, and maybe even hopeful. Remember how one of those key vibration frequencies was in the megahertz range? Well, what else do we use that operates at that exact frequency? Medical ultrasound. So the idea is, maybe it's possible to use a very low-intensity, non-invasive ultrasound to gently ring those microtubules, almost like a tuning fork, and coax them back into a healthy, stable, vibrating state. It could be a completely revolutionary kind of therapy.
Okay, so we've talked about the brain, about memory, even about a new approach to Alzheimer's, but the theory doesn't stop there, not even close. It goes even deeper and starts to tackle the biggest questions of all, like what even is consciousness, and where did life itself come from?
You know the story we all learned in school, right? It's pretty straightforward. First, you have a bunch of random chemical reactions in some primordial soup, and poof, life evolves. Then, way down the line, brains get more and more complex, and eventually, somehow, consciousness just sort of emerges as a side effect.
But what if that whole story is completely backward?
What if consciousness isn't something our brain produces, like a generator making electricity? What if it's something our brain receives, more like a radio tuning into a signal that's already there? This radical idea proposes that consciousness, in some very basic form, is a fundamental property of the universe itself. It's woven right into the geometry of spacetime. Life didn't create consciousness, life evolved to access it, driven by what Hameroff calls a quantum pleasure principle.
So in this new origin story, the reason for life to exist was there from the very start. You have these simple molecules, maybe some aromatic molecules from space, that are capable of a basic kind of quantum feeling. And they don't just organize themselves randomly. They organize themselves in ways that lead to more pleasurable states and help them avoid unpleasant ones. So feeling wasn't the end product of billions of years of evolution. It was the engine that drove it from day one.
And that leaves us with one last, pretty profound thought to chew on. For billions and billions of years, the universe was just silent, unfeeling. But maybe, just maybe, through this incredibly intricate quantum dance happening inside the microtubules in our brains, maybe we aren't just a tiny, insignificant part of the cosmos looking out. Maybe we are the way the cosmos finally gets to experience itself.